cloud system because these are sensitive data, same as a bank. The bank is not going to use a cloud system because they want their own server to keep the transaction, to keep their customers secure. Okay, I'm not saying that cloud computing is not secure, but there's a certain system like that where you have to look at about the platform as well that you're going. So sometimes it can be costly. Assessing whether there's technology in existence that meet the specification. So I was telling you earlier that there's certain facilities like the supermarket, there are new proposals, but the cost might be high, or the technology is not available for the time being for you to be able to put into place. Same as solar energy. Some 10 years back, no one would have invested in putting solar panel on their house. But nowadays, with the cost reducing, more and more people are doing, I call it the grid, they're selling to the CB. So with improvement in technology, there are things that you can propose nowadays. Assessment of a development organization ability to construct a proposed system. So if you're proposing a solution, you need to have people that can, or you have infrastructure also to develop such kind of system. Okay, like for example, in Mauritius, no one can come and say that we are going to build airplane or we are going to build car because we don't have a facility, we don't have this expertise. Even I was looking at a documentary about car in Russia. So they invested massively to be able to develop quality car in Russia. Okay, so it's quite a big investment, expertise required from different fields in order to be able to implement something. But IT, hopefully, we can implement lots of interesting projects in Mauritius. Operational feasibility. So whether the human skills, we have human resources with appropriate skills to operate the system once installed. Okay, we don't want to implement very complex project, then realize that we don't have the human resource to handle this. Like for example, if you take hospital, nowadays in hospital, you have lots of interesting scanners to monitor the health of people. But if you have, and usually, I don't know if you've been to this clinic, and usually these scanners, they have a software system behind that's going to monitor your health, but you need people with expertise to operate that. Okay, so very often we have training given, but sometimes it's quite complex. So whether the system will operate and be used once it is installed, so very important, you don't want to invest money into a project that eventually people won't use it. So I was telling about user interface. So if you adopt some kind of templates, GUI templates, obviously this is going to be easy and going to be adopted by people. And success of software development nowadays rests a lot on the user interface. Human resource feasibility. Are the users happy with a new system or are they apprehensive? So normally this is gathered during the analysis stage when you're going to talk to your customers, users, people that eventually will use the system. You know whether they want this new system or not. Like if you go back some years, people were apprehensive of the Metro Express. But once it has been launched, people are, I think lately they say that lots of people are taking and they are getting the benefit that they expected. So lots of projects are like that. Okay, so you need to make sure that eventually the users, the customers of the software will be happy with the new system. Do we have sufficient dedicated and qualified staff to deploy on the project? So this is from a developer's company perspective. So if you have a project that you propose, the project manager, the CEO of the company will decide whether they have human resource to deploy on that new project. Maybe you have a very good idea, but at the time being, unfortunately, they don't have the personnel to work on that. Okay, so this project will be put in a corner, and eventually, after some years, maybe we are going to implement it. So do the staff have time to be involved in the development process, requirements, meeting, tests? Okay, so all these should be evaluated. Economic feasibility. Very often we have a tendency to relate whatever feasibility is to economic feasibility. It's not always the case, because I told you that very often in project we have tangible cost, tangible benefit and intangible benefit. Like, for example, when you put a website for your business, the number of customers, especially nowadays, lots of people are online. So we have lots of marketing being done online. When you open any website, you're going to see that they're going to advertise a number of products based on your pattern of you visiting such website with such products. So they recommend that to you. So a lot of this being used nowadays. So sometimes we say that we don't have privacy nowadays, because they are monitoring everything that you're doing online, okay, without you knowing. So here in economic feasibility, we're going to demonstrate that the proposed solution will bring along profits or will minimize loss. Okay, so the different costs of current system and new system are considered. So there's two aspects. One, you're going to consider the cost of the old system with the cost of new system. Okay, and whether it's going to be worth investing. And the other aspect is to compare the cost of a new system with the benefit that you're going to get, whether you're going to recover the amount of money that you've invested. But hopefully nowadays, lots of companies are willing to invest in computerized system. Okay, there are few companies, not companies, like, for example, even in government operations, there are opportunities to computerize their system, but unfortunately, it's not done. Okay, slowly they are doing it. They started with, for example, the MRA. So everyone knows that the tax form that you fill, it can be easily done online, but there are many other facilities government provide that could have been computerized. So initial costs associated with the development, running costs with day-to-day running of a system, and obviously you're going to get profit arising from sales or services improve. We have schedule feasibility, another important aspect of software development. So basically there are three main things that we focus when we, well, I'm not saying that the others are not important. So first, we need to focus on the requirements that are going to go extensively in software engineering. So we need to make sure that our software meets the requirements that the customers ask. We need to meet the cost of a project, and we need to meet the schedule. So these are what we call the triple constraint of software development or any software project. And the schedule feasibility, normally we do that through a number of techniques, like, for example, a network diagram, we have Gantt chart, we have Kanban, you have a number of techniques that is used in order to make sure that the project will be completed within the amount of time that has been specified. And if this schedule is exceeded, normally you're going to lose money. For example, if you've, depending on the type of contract, okay, if you've done a fixed contract with your customer, saying that it's going to be done in 6 months, we are going to get, let's say, 1 million. Now that project, instead of 6 months, it goes to 7 months. So basically that 1 month you have to remove from your profit and pay your employees because they are going to work on the project. So that's why it's very important to do properly your schedule. It's not an accurate science. You're going to see it's not easy to do that, but with experience, these software developers, they can estimate more or less accurately. There are a number of techniques that we're going to do. So one of them is precedence table, where you have the task, the duration, the dependencies. We can play with that. And we can draw what we call a network diagram. We can do what if analysis and analyze if you change the duration of that, what will be the impact. And there's this concept of critical path where we can identify what activities are most vulnerable, meaning that if we change the duration, this will impact the total length of a project, like for example, a house. So if you have, for example, the base, the roof, the base, the walls, the roof, now you have doors and windows, aluminum that you are preparing. So you can delay that production to a certain amount of time. But now if your house is ready, but the doors, windows are not here, obviously the person cannot go and stay there. So there are things like that in software planning that we can do. We play with the dependencies, where the tasks are, and the duration that. So this is all about schedule feasibility. So basically, what is system analysis? We've been talking a lot about that, is understanding what we are going to do. Okay, so whenever we talk about analysis, is getting to know the customer's need. We need to know the inputs, we need to know the outputs, we need to know the problems, we need to know the processing that needs. High level, we are not going to go into detail about exactly how this is going to be implemented. So basically in system analysis is what is to be done. Okay, what is being done is functioning, the volume of transaction, the task, whether it's being performed well, the problems that is facing, because whenever we are doing a computerization, obviously we want to improve it. Okay, there are many possibilities to improve, many alternative solutions. So we need to understand the problem first, then we can. So in analysis, normally what we do, gathering requirements, functional and non-functional requirements, modeling the user's environment using DFD, EOD, state diagram, use case diagram, sequence diagram, class diagram that you're going to do throughout this module, this semester and next semester. So this is basically analysis. So it's saying my connection, internet connection is unstable. Is it okay? Can you hear me? Can you follow?
Yes.
In case there's
Yes.
anything, don't hesitate to.
Yes.
Okay, thank you.
Yes.
So let's proceed. So this is about analysis. Now coming to design. So what is design? Basically, it's translating what you gathered in analysis to how this is going to be done. Okay, so if we talk about design of a software project, normally there are different aspects that we focus. There is what we call algorithm design. So we are going to, for example, you have a reservation of hotel room. So we are going to do step by step how this is going to be done. So we are going to verify the customer details. We are going to check whether there's room available. We are going to book the room that the customer wanted. We are going to give the price to the customer. The customer is going to make a part payment. Then we're going to store that booking somewhere. Okay, so this is the algorithm design. The entity relationship diagram. So in analysis, you see that we have EOD. So this is going to be translated to a database, because if we take the hotel room booking, so in your database, you have basically the rooms available, whether it's the number of rooms you have, whether it has been booked or not for that period. And once a customer is going to make a booking, you're going to set the status to book. Okay, so these are the database design. Then you have a user interface design, because whenever you have an application, you need to have an interface for customer to interact. So whether it's going to be a mobile app, a website, you need to have a nice interface with, for example, surname, first name, address, telephone number. Okay, then the amount of room required, the number of people that is coming, the days. So all this will be provided. Then you're going to do the processing using the algorithm, and then you're going to present a nice output saying your room has been booked, please make the payment and things like that. So this is basically the user interface design. There's also sometimes the data structure. Okay, whenever you have a customer information, you need to decide the components, the fields that you'll have. So in the database design, we are looking at this, but sometimes we have also the data structure for the programming part. Okay, whether it's going to be a class, whether it's going to be a procedural language with structures and so on. So you have to decide about this in the design as well. And very often in design, we also do what we call flowcharts. Okay, we'll discuss about that. So we are going to look at in analysis, but people sometimes include it also in design because stepwise showing the different steps and the inputs and outputs. Then implementation. So once you've been able to understand what is to be done, you know how it's going to be done, you just have to translate it. Well, it's not that easy, but at least if you've gone through the life cycle model, you have a better understanding of the system, and eventually you'll get experience in coding. So you can easily translate, for example, you have a reservation of hotel room, you can easily write a piece of code that will take this input, match it with whatever data you have in your database, suggest rooms to the customer agrees, and you just update the status. So this is the actual implementation. So this involves mainly the coding and integration of module into more complete system. And depending on the life cycle, very often it's a repeatable, iterable process with a number of outputs showed to the customer because you need customers' feedback. You need to show to your customer, get their feedback, make improvement, and so on, because you have to work. Most life cycle nowadays is to work with customers. And eventually you have the testing aspect. There are different levels of testing. Hopefully next year you're going to go into detail about that. But one important thing of testing, it has to test both correct behavior and incorrect behavior. Like for example, you take the ATM. If you go to the ATM, you want to test the ATM. I'm going to take a correct card with a correct PIN. I'm going to test it. Now, I need to test also with a correct card, but expired PIN. Okay, so to make sure that the system is really validating before letting me getting access. So this is about testing, and you have different levels of testing as well, because in testing, whenever we are doing implementation, we have to test whatever we've written. So this is called unit testing, and basically you're going to do that in programming. I guess you're doing C++ programming. So whenever you're going to write a piece of code, you have to test it. Okay, this is called unit testing. And once you've done a unit testing, it's working fine. It's not guaranteed that it's going to interact with other code. So that's why, because you can imagine that nowadays with a complex project, we have so many lines of code, so many units interacting together. We have to make sure that they work together. So this is where we have module testing, subsystem testing, and eventually system testing. Like for example, university, it can be broken down into library, finance section, registration of student, academic facilities, and things like that. So when you go to the library, you have reservation of book, you have payment of fine, you have ordering of book, you have many. And when you go to reservation of book, you have to search for the book, you have to search for the student, you have to validate, you have to reserve or rent the book and things like that. So there are individual code that is written, tested individually, combined together to do module. Then this module combined to form the library subsystem, and eventually the library system will be integrated together with finance, because when you make payment of fine, the money will go to the finance. When you order book, you have to ask money from the finance section. So this is how they interact, they communicate with each other to eventually form part of the final. There are systems as well that are standalone. They don't interact with anything. Like for example, Word. You download Microsoft Word, it's running on your machine, you write a text, and it's not interacting with others. Okay, it depends. But when we are implementing, very often it's broken down into different subsystems, different modules, and different units. And we have to do that integration testing approach. And eventually we'll have the installation and deployment. So there are different ways of going this. So different methods that normally we use, a parallel approach, both old system and new system run in parallel. Direct approach, scrap the whole and replace by new system. But unfortunately, sometimes it might crash, like MCB, internet banking, some years, or maybe quite some years now. But they decided to scrap the old system and put a new system, but unfortunately, the new system crashed on the day it was launched. So there's a risk involved when we go for direct. And the phase approach, normally here on campus, we do that. So we do department by department. So we change from old system to new. So a department is using it, testing it, giving feedback, we improve it, and then we go it to other departments when we're sure that it's stable and can be used. Yes, any question? Yes? I cannot hear properly. Can you just write the text or please speak louder? Yes, someone was talking. Any question? Okay, so if there's no question, we'll just proceed. Okay, so if there's anything, don't hesitate. So we were the installation deployment. So here it is. So each company might go for their own strategy, how they want the system. If they are confident that the system, they can go for direct. At university, we have a tendency to go to make sure that the risk is less. And so this is installation. And then eventually we have maintenance. So once the system go live, we call that go live, it's being used by the customer. Very often, there are some errors that's going to be discovered, unfortunately, because no testing phase has been 100% accurate till now. It's still when we release the code, the software to customers to be used, we are going to get some errors. So we have, well, even if we don't have mistakes, sometimes we have to do maintenance. For example, a car, when you purchase a car, you can't just use the car every day without doing maintenance. At some time, it's recommended to do maintenance. So the maintenance, the process of changing a system after it has been delivered. So we have three different ones: perfective, adaptive, corrective. So perfective maintenance is changing a system to make it meet its requirement more effectively. So it might be due to increased number of customers, or you have the hardware that has been changed. So you have to modify the software to meet that new platform has been changed, the operating system. So this is perfective maintenance. Adaptive maintenance, changing a system to meet new requirements. So for example, some years back, we didn't have online payment, but with changes, with more people adopting online payment, so we have to change our system to interact with banking system in order to allow this transaction to be done. Even some years back, we could not pay bills, for example, CB, CWA, Mauritius Telecom, and nowadays most of them insurance we can pay online. Okay, because with pandemic, we realized that we have to make changes to the system. So we have adaptive, we have corrective maintenance. I tell you that when we release a system to be used by customers, very often they'll uncover some bugs, some mistake, and we have to correct this. And even if it is a standalone system, let's say, for example, you're using an application that you've downloaded and put on your laptop, you're using it. After some time, you see that there's a crash, and then it's going to ask you, do you want to send an error report? So basically what they are doing, they are informing the software development company that there's an issue. They are going to track down the issue, they're going to resolve it, and obviously they're going to improve and release a new version. So this is corrective maintenance. Okay, so basically some qualities, it's not an exhaustive list because just some aspect that we are going to focus, but when you do other module, like for example, software project management, we'll go into more detail about skills required. So an analyst should be able to, so basically they require some soft skills in addition to technical skills. So first one is problem solving. So we said in the first few slides that when we talk about analysis is trying to find solution to problem. So the analyst should readily identify problems and then evaluate alternative solution. So someone that can propose solution to problems identified. So this is one quality of analyst. Critical thinking. So computer experts should be able to use logic and reasoning to identify possible solution to problem, and they need to find the best approach to solve complex issues. So this is another characteristics, if you want, of analysts. Patient, so they need to talk to customers, they need to understand. It's not easy to work with customers because their views, their ideas might change every day, but as analysts, you need to gather their needs as well as you need to abide by the schedule and constraint. And there are certain things that sometimes is not feasible. You need to explain to the customer that it cannot be done at this time. So this is another people skills. So you must be able to work with a different variety of people, customers, staff, because you're going to be the bridge between the customers and the designer. Whatever you're going to gather from the customer, you're going to represent that in models, in documents, that's going to be transmitted to the designer and eventually to the developer. So excellent communication abilities. So you need to be able to write reports, to present something, to resolve conflicts, to explain to customers that there are certain things that cannot be done based on the schedule constraint, based on the cost constraint, and based on the limitation of the infrastructure, the hardware. Okay, so that's it for first lecture. Any question about what we've covered in first lecture? I'm sorry, we could not complete that last week. So any question, don't hesitate. I know I have a tendency to go very fast. So if you cannot grasp anything, don't hesitate. If you cannot follow, please stop me. Okay, I have a tendency to talk, but you're here to learn things, to understand things. And basically the theory you can get everywhere. You just read any document, is going to be more or less the same thing that we're covering. What you need to pay attention will be the notation that we're going to use in second lecture. Be careful. Okay, don't use any other notation given in books or on websites. No question? You want me to go to the second lecture right now, or? Yes. So I know some of you joined today. I'm sorry for that. But anyway, it's just introduction. You can go through lecture slides. If you don't know how to get access, ask your friend how to get access to lecture notes, or I'm going to send an email for the Google Classroom for you to get access. You want me to go to second lecture, or you want a short break? Question, normally when it's, for example, introduction Lava is going to be straightforward theory question. Define, explain, what is, okay, this kind of question. But as I told you, it's an applied module. Yes, so if you have any queries, you can ask me in the next tutorial session that we'll have, or you can ask me in the chat box, or you can ask me by email. And for the time being, don't bother too much about exam. You're here to learn, okay? Focus on the learning process, then we'll look at test and exam. So you want a short break, or you want me to go to the second lecture right now?
We can continue.
Okay, 5 minutes. 5 minutes break. Then we'll start with the second lecture, DFD. Okay, welcome back. So we're going to proceed with our second lecture. Are you here? It's okay, we can proceed.
Yes.
Yes.
Okay,
Yes.
so let me share the screen. Second lecture is about data flow diagram. Let me share that screen. It's okay, can you see?
Yes.
Yes. Okay.
Yes.
Yes.
So today we are going to basically look at an important tool in software analysis and modeling. It's called data flow diagram. And we are going to look at the notation. And in the end, I'm going to give you a simple case study to explain to you how to translate that case study into a DFD model. And as far as possible, I told you we are going to use whatever notation I'm going to explain in the lecture. Though there's different notation that you have in books, like for example, you have Jordan notation, you have some newer model, but this one is by Kendall and Kendall. So this is the one that I'm going to use. And it's going to be easy also for all of us to follow if we use the same notation. So we are going to talk about structured analysis this semester. Next semester, eventually you're going to talk about object-oriented with difference modeling, like a use case, class diagram, and so on. So structured modeling is in line with structured programming or procedural programming that you do in C++ for the time being. Eventually, I guess you're going to do object-oriented programming. So that's why we are going to explain both. Okay. So structured analysis and modeling use a graphical diagrams to represent specification because it's easy to understand rather than writing. I'm not saying that writing text is not required, it's not useful, it takes more time, and sometimes people don't like to read through a whole bunch of text. But a visual representation of our system with basic or simple notation that everyone can understand is going to be easy to communicate, whether it's between analysts, designers, analysts, customers, or any other people involved, like for example, the CEO. CEO don't have time to go and read a 100-page document. They want something that visually communicate all the information that is required. So this diagram will describe the steps that need to occur in the data required to meet the design function, because it's an important phase of going to implement. And we have to go through the analysis stage before reaching the design stage, before reaching the implementation stage. Even if we take, for example, Agile is not going to use the same model as us, is going to use user stories, scenarios, but we need some kind of modeling. Okay, so structured analysis is a data-oriented approach. So that's why we are focusing on data flow diagram. The name itself is saying data, and it's a modeling approach, meaning that we are going to draw visually on paper. That's why we call it a model. We're not going to implement any system. We're not going to use any prototype. We're not going to use any platform for the time being. It's just from a textual description about the system to a visual representation. And very often it's an abstract way of presenting our solution, because if we put it into too much detail, it might be complex for people to follow. Okay, I'm not saying that I'm underestimating the expertise of your designers, of your developers, but very often to represent things, it's better to start with an abstract. If you like the high-level model, then you can go into more detail. So we are going to look at the system from a data and processing perspective, but we're not going to focus about how it's going to do it now. So at this stage, it's going to be only the inputs, the process, the outputs. So this is why we start with a data flow diagram. So basically in structured analysis, the number of steps that we have to go through. If you recall, I said that structured development life cycle tell us what is to be done, but it's not going to tell us how to do it. Okay, you're going to learn hopefully as we go through. So we need to understand the current business environment, the what purpose. We need to understand the old system, how it functions. We need to propose a new system that is in line with the old system with certain improvement. That's why very often we have the logical, we have the physical environment, the boundaries, the addition of new. We need to evaluate alternatives. So in analysis, we do evaluate alternatives by comparing, for example, the platform that we can use, the algorithm that we can use. Okay, so we do some evaluations sometimes. We select the best design and we write down the technical specification of this. But we're not going to go in all of this today. So today we'll focus mainly on how to translate the textual description of a system into a visual representation of the system. So the analysis is going to model the system the user wants. Is going to be an abstract representation of the real system. Why we are focusing on the term abstract? We don't want users to get lost. For example, if you want to design, let's say for those of you who like to do drawing, you want to model a new car. So there's no need to go into the detail of the engine of a car at this stage. You can draw the car from outside perspective with a view of the doors, the wheels, the front side, the back of the car, just to get a view of a car. Once you like the visual aspect, then you can go into detail about, for example, inside, how the seat will look, the dashboard and things like that. So first you need to get the high level, you like it, then you can proceed further. So with DFD as well, we are going to see in subsequent lectures about exploded DFD and so on. So why modeling? We are going to focus on important system features while doubling less important features. So we are going to manage the complexity of the system. Certain information we are going to get at this stage in the case study. So case studies also, we can't write 3 pages of case study. So it's going to be 1 page, around 1 page case study, so that you can get enough information to come up with. But if you go to industry, when you're doing investigation, the description of the system might be very big, okay? But we can't do otherwise. We have to gather the requirements. We need to understand the system. So, but for the time being, with our case study is going to be small. But at least you know the concept, how to translate it. It's going to be easy to apply to any system afterwards. So discuss changes and correction to the user requirements at low cost, as I was telling you with car. So there's no need to do any prototype, any development of the car. You do on paper. If you like it, you can go into more design. And eventually, when people are satisfied with every aspect, with the engine, with the interior, with the exterior, then you can go and do a prototype. Okay, those who follow, it's quite a long process. Okay, we have what we call concept car. So they go through a number of steps first. Make changes, correction, users feedback, and then we can come up with the prototype. So to verify what we've understood in the user environment, because very often when we talk to customer, they have something in their mind. The way they are describing it is not quite how you are understanding it. So with modeling, you can go to your customer, show them, make correction, till you get something that is both parties going to agree. And it's easier to build a new model and change it compared to a system, obviously. Okay. So we're not going to do any prototype at this stage, it's just paper modeling. So a good modeling approach, first thing, very important, graphical. Whether it is a software model, a building model, for example, architectural design. So those of you who've been in the process of constructing house together with your parents, you recall that basically you have architecture diagram that is done. If you like the visual aspect of the house, then you go into more detail about the rooms, okay. So this is why we do a graphical representation. If you don't like it, you can just scrap and do another model. So most popular models rely on graphics. A well-chosen picture can convey enormous amount of information concisely and compactly, and we can discuss with customers, with designers, and eventually, if you don't like, you can do another one. So we can use graphics to identify components of system and interface between these components. So this is the different types of models that you've come across. Today, we're going to focus on data flow, but eventually we are going to have what we call deployment diagram. We have module diagram, we have cross diagram, we have sequence diagram, we have activity diagram, we have flowcharts, we have ERD, entity relationship diagram. So we have a number of, you have data dictionary for the data structure. So different ways of representing things graphically. But very often, only a visual representation is not sufficient. So it's good to have some textual representation that you add. So with your diagram, that's why in DFD, ERD, whatever we are going to do for this module, as far as possible, write down some assumption, okay? So that the person reading the diagram know that this is some constraint, this is assumption that you made, and this is why you came up with such a model. So it's good to write some basic assumption. About two or three is sufficient. Allow the system to be viewed in a top-down partition fashion. So most models will start with a high-level view of a system. And in DFD, there's what we call a context diagram, often referred to DFD level 0. So we start with a high-level view of a system, then we go into more detail. But for this, for test and exam, due to the fact that we have limited ways of, because I won't be able to ask you to draw a number of diagrams. So that's why very often we'll go to DFD directly. But if you want, for case studies that we are going to tackle, if you want to do the context diagram, then you go for the DFD, that's fine, okay? So normally we start with a high-level view, then we go to DFD, and from DFD, then we go to explore the DFD, okay? So in most large projects, it is impossible to focus on an entire system at once. For example, university system is quite complex. I explained to you library, finance, registration, academics section, and things like that. So we can go for a high-level view. Even if you take, for example, the Atlas, when you start, you have a high-level view of the country. Then you go into subsequent page, you get the district, and in the district, you'll get the roads, you'll get the, for example, mountains, rivers. Okay, so this is basically the idea of modeling approach. Have minimal redundancy. So as far as possible, we want to limit the information that we are putting in the diagram restricted to one level only, so that we don't have, in case we have to change, we don't have to change too many diagrams. sometimes it's impossible, but as far as possible, we are going to focus on one aspect of a system. And once we've mentioned this information in one diagram, we're not going to repeat it in subsequent diagram. Okay, unless required, we're going to see as we proceed. So models represent dynamic system. Hopefully, customer is going to give their feedback. There will be changes, so we have to do models such that we can make the changes easily. So have minimum redundancy between our models so that we can make changes. Be transparent to the reader. So as far as possible, we are going to use simple notation so that it's easy for them to understand, to grasp, so that they don't spend too much time in trying to understand the notation, so that we can discuss with them. Okay. So data flow diagram. Anyone? I guess you've come across this term before. Yes, anyone has? Sorry. Anyone can explain what is DFD that you've come across? You can unmute and talk, or you can just write in the text box. Someone saying that is like a flowchart, if you want, but they are completely different. Okay, but DFD is more high-level concept. It's not about flowchart. It's more how things are going to be done step by step. We're going to see it later, but a top-down approach. Yes, DFD will use a top-down approach. It's a good modeling tool. No, it's not like state transition diagram. State transition diagram is more technical. At this stage, we are trying to understand. We don't want to bother your customers with technical aspect at this stage. Okay, someone saying whether it's like brainstorming. No, brainstorming is something that is used to gather information that will be used to draw your DFD. Okay, you'll come to that when you do cover the topic about interview, gathering data. So it's, yes, graphical representation of the flow of data. Yes, very important. So the name says data flow. So in all computerized systems, you'll have inputs, you have processing, and you have outputs. Like the booking of room, you have customers going to provide some inputs, you have a processing to be done. And once the processing is being done, you have some outputs that goes to your database or it goes to your customers. Yes. Okay, so let's proceed with the lecture. Okay, so let me go back to. So a data flow represents an input of data to a process. It represents the process and the output from the process. So we are focusing on data, how it is flowing through your system. We focus on the inputs that entity is going to give, or we are going to extract from data store, or is going to be also showing the data that moves from one process to another. Like, for example, whenever you are making a hotel room reservation, obviously you have a payment to make. So once you've selected the rooms that you want, we have to transfer that data to the next process about calculating the amount of money that you need to pay. And if you're doing a part payment, we're going to do a part payment, we are going to store it in a file, then later we need to trace back that you give the full payment afterwards. So there's another process that will track this full payment. So I guess you've understood the concept of the data flow diagram. So Advantage is going to structure the mass information analysis discovers. Someone mentioned about brainstorming. So brainstorming is one of the techniques that we use to gather this information, or it can be interview, it can be questionnaire, it can be reading from online website about the company, documents that we have about the company, or in other books. Like, for example, you want to know how a banking system function, there are plenty of documents. There's no need to go to SBM to understand that. You can refer to documents available and understand this information. So it's going to be used as a means of communicating with your users. So we structure whatever information we gathered, then we show our model to customers. They are going to tell us whether we've missed any process, we miss any inputs, there's important outputs that should be given that we miss. So this is the idea of doing a DFD and clarifying it with customers. And we'll give further understanding of interaction between system and subsystem, because at this stage we are focusing on the high-level view of the system, but obviously we can decide that, for example, this particular aspect is for library subsystem. This one is for payment. This one is for this one is for finance. This one is for registration. So we can understand the interaction. And there are other diagrams. When we do deployment diagrams, module diagram, we decide this process is in which module and so on. Okay, at this stage, it's just high-level view for the time being. So let's start with the symbol. So again, you're going to use whatever notation I'm going to teach you. Okay, I'm not saying that you should not refer to books or to online website, but when we are going to do case studies, we're going to do a test and exam, you need to abide by this notation. So you're going to see that this symbol is quite easy. So first one, entities. So when we were talking about the hotel booking system, so entities are anyone that's going to provide inputs to the system or expect output from the system. So we use a rectangle. Why we put that shaded border? Because normally it's not one entity. Okay, when we talk about customers, there will be thousands of customers, hopefully, for our business. Okay, so that's why we put, but when you're doing it on paper, there's no need to put the shaded. Okay, it's okay, I understand. So just do the rectangle, that's fine. But if you're using, for example, a tool, maybe there's the shaded border, maybe there's not. Okay, by the way, you can use star UML to draw your DFDs. So example, student. So university system, one entity that you have is a student. The student is going to provide inputs like, for example, the student details. Then the process will be registering that student. So arrow to represent data flows. Very important that you should not forget all notation that we are going to come across, it has to be labeled. Okay, I'll explain the rule later. So you see that, for example, you have an entity, you need to label it. With student, you have an arrow, so new student information. And arrows, as far as possible, it should be directed arrows. Okay, so that I need to know whether it's an output that is going, whether it's an input coming. Okay, it has to be directed, but some diagram you're going to see they don't put the arrows, but it's quite difficult to follow. A process, so it's a, I don't know the actual name of it, but basically it's a rectangle with rounded corners. Okay. And there's a separation. So the top level of the process is for the unique identifier, and the bottom is basically the name of the process. And you see the rule about how to label a process later. So example here, 2.1, create student record. So this is the notation for a process. Now, if someone, when they are drawing, they put a rectangle, they don't put the rounded corners, I'm not going to penalize you for that. Okay, the notation is like that, but sometimes when we draw, we forget to put the rounded corners. You're not going to penalize. Everyone will understand that. Once you put the unique identifier, you put the label, everyone will understand. But as far as possible, we try to stick to whatever notation. Data store. So it's going to be like that. So we have a sort of rectangle with one open side with it. and there's a small shaded box. You can shade it, you can leave it blank, where in that shaded you're going to put the unique identifier, and then you're going to write down the data store name, okay, like student file or student master, student record, payment record, customer record, product file, okay, any name. The labeling we'll see, but you have to label it, and you have to put that unique identifier. Normally it's D1, D2, D3, because when we repeat the data store, we are going to use the same D3 with the same name. So this was, you see, very few notation, but that doesn't mean the DFD is going to be easy to draw. Simple notation, good modeling tool, but to convert will be very difficult. So what is an external entity? So it's with which the system will interact: individuals, group of people, departments, external organization like bank. Okay, it can be anything that is providing input and expecting output. And as far as possible should be labeled with a noun. Okay, like customer, person, student, bank, cashier. Okay, so these are things that we label. Data store shows a collection of data the system needs to remember, like student record, customer record, payment record, again named with a noun. A process represents the individual function to the system. How it's labeled, normally it's a verb followed by an object. Create a student record. Search a student data. Print, customer, receive. Okay, this is basically, it's normally starting with a verb. Sorry, and there's a unique identifier above. So for the DFD is going to be 1, 2, 3, 4, 5. Okay, the order doesn't matter, but each process will have a unique identifier, because when we explode, then we're going to explode according to that label that we've used. If it is 4, it's going to come 4.1, 4.2, 4.3. Now, if you explode 4.1, it will be 4.1.1. So we can relate that 4.1.1 is the process that is exploded from 4.1, and 4.1 is a process that has been obtained from 4. So that's why we put that unique identifier. Data flow, just showing the inputs and outputs, and as the name suggests, it has to be data. DFD is a data flowing through the organization. Like, for example, you go to a company to purchase a good. First, you need to give your contact details. You need to give details about the product that you want to purchase. The person is going to check and tell you whether it's available. Then you have to agree that you're going to purchase this quantity, and then it's going to produce a receipt. You make the payment. So it shows data that is flowing through the organization. Well, the way I'm saying it looks simple, easy, but it's not that easy when you get a case study. So first level of diagram, I told you it's a DFD level 0. It's referred to context diagram to avoid confusion. Very often I'm going to ask you, draw a context diagram, and the other one I'm going to refer to DFD. Okay, but as I told you, very often I'll move directly to DFD. But if you feel that you're getting issues to understand the system, it's good to start with a context diagram. So what is a context diagram? It will be an overview of a whole system with one process representing the whole system, and then we'll have the entities, the inputs they are providing, and the outputs they are expecting. So no data store will be shown on context diagram. It's just a diagram that is used to represent the whole system for us to understand what the system is about. So don't forget, analysis is what. So everything we are going to do is trying to understand the system. So context diagram indicates the people, organization, system with which we communicate. It shows the inputs and outputs. So what is the data that is required for the system? What is the data that will be produced and to where it's going? For example, customer gives customer detail as input. We are processing, we are returning the customer payment to be made. Okay, so this is the output that will go to customer. It shows also the boundary for us to understand that we are focusing only on selling our products. Now, if you have stock control on it, you'll put the stock department, so whatever. So here is an example of a context diagram. It has only one process, the process 0, which is basically, for example, the hotel booking system or hotel management system. Then you have entities, customer providing the customer details. You make the booking, and there's the payment to be made that goes to the customer, and you have the amount of money maybe that goes to your accounts department or whatever. So a context diagram will have only one process with the name of a system, the different entities interacting with their input. And now here is just an example. So entity 1 is providing input A. If entity 1 is expecting an output, then there will be an arrow from process 0 coming back. That's why we put the directed arrow. As far as possible, avoid bidirectional arrow. Okay, in some diagrams you might see that where you have an arrow with 2, meaning that there's an input as well as an output coming. Okay, but if you can avoid it, because with bidirectional arrow we might miss that there's an input, there's also an output coming to the entity. So this is context diagram. Any question about that? Okay, so any question about context diagram before we move to DFD?
No.
Is it okay? You can follow, not too tiring. No? Okay, good. We proceed. Sorry, this one. So next level DFD will be like that. Okay. So after we've done a context diagram with only one process, the entities involved and the inputs and outputs, then we are going to draw a diagram like that. Well, there's no need to shade the process, the data, so it's just showing a boundary. So we'll get a number of processors. In this case, there are 4 processors. We'll get a number of entities. So we have entity 1, 2, 3. So this was mentioned in here. So entity 1, 2, 3, whatever you've done in your context, and a number of inputs that basically has been mentioned here. But due to the fact there will be data exchange between the process, we have to show them as well. Okay. So there's input A that is given by entity 1. We have a process. This process produces an output that goes to process number 2. Process number 2 gets an output that goes to entity 3. Then process number 1, there's also a data that flows to a data store, to data store 1, data store 2, and it goes on like that. So this is how we construct our DFD. And you see that all entities will be labeled, all processors will be labeled, data store labeled. You see D1, D2. Okay, you can use any number. Someone might call this one D2. Okay, then this one D1. It doesn't matter, but it should be labeled, and all data flows should be labeled, and arrows indicated whether it's an input coming into the process and output going from the process. And there are a number of rules that we are going to see that you need to check after drawing your diagram. So the first rule that we are going to see is a DFD includes 9 processes. So for clarity purpose, for simplicity for us to follow, we are going to try to stick to that rule. So whenever, and most case studies that you're going to come across is going to be maximum 8-9 processes. If you're getting more, meaning that you've not done the case study properly, or there's possibility to combine, but you didn't combine the processes. We'll look at that as we proceed with tutorial session. So as far as possible, you know that the maximum number of processes will be 9. Okay. So each external entity should be labeled. So you've seen in that, and normally it's a noun. Each process should be labeled. So you've seen here 2 sections. First one is the unique identifier, and followed by the name. And as far as possible, I told you the name should be starting with the verb followed by an object. Okay, defined as an active verb in the imperative plus an object, but we don't indicate who and where it's done. Okay, for example, here it's print sales report. We are not going to say that the cashier is going to print the sales report, or the accountant is going to print the sales report. We don't indicate that. It's because we are computerizing. We are considering only the process. For example, check creditworthiness, verb, the object. Okay. Now, some rules that you need to pay attention. All processes must have inputs and output flows. You can't have a process because the basic idea of processing is to convert data into information. This is simple definition that you've come across in IT. So we are going to stick to that. So all processes that you do should have inputs and outputs. So you can't have a process with only inputs like shown in this diagram. Calculate gross pay. There's only inputs, employee time record, employee record, gross pay coming into. So it doesn't make sense to have a process with only inputs. There should be some outputs going. So if we go back to the diagram, you're going to see inputs, outputs. So you have inputs, you have outputs, inputs record A, and you have inputs input B, then you have output data flow, and there's input data flow D going to 4, and there's output record E. Okay, so all processors should have both inputs and outputs. Now, the number of inputs and outputs that you get in a process should not be equal. So people have a tendency to say that when you have 2 inputs, you need to have 2 outputs. When you have 3 inputs, no, there's no rule about that. So be careful. So if you have a process with only input, so basically you need to find out why and what is the expected output. Okay, so you're going to add the output, or you have a process with only output. So a process cannot function. You need to find out what is the source of the data. Okay. Then you modify your diagram accordingly. So it's very important to check all your processes should have both inputs and outputs. Each data flow should be named and directed. Okay, so like for example, invoice, payment details, customer details, student record, student results. So all these will be data flow. So all data flow should be labeled. Each data store should be labeled with a unique identifier, normally starting with D1, D2, D3, and with a name. Okay. But in data store, it's possible that you get a data store where you're only storing data to it, or you're only retrieving data. In this case, you have both input and output from the data store. In this case as well, you have both input and output. But it's possible that you have a diagram, like for example, here, you have record E going to that data store 2. There's data flow C going to that data store, but there's no output, that is, there's no record E going out. So it's also possible. So with data store, it's possible to have data store with only input or only data extracted from it. So data store with only input data implies that we have some kind of write-only file. Data store with only output data flows imply that we have some kind of read-only file. Okay, for example, you're extracting data from bank account, but you're not processing the bank account to make updates. Okay, just extract the data from there and you use it. But in certain case, when you're computerizing the system, you're going to realize that maybe you made a mistake. Like for example, stock, you cannot just retrieve data from the stock. At some time in point, you have to update your stock. So there should be a process to update the stock. When we do logical DFD, we are going to talk about that. Wrong link. So you have to be careful in data flow diagram. So there are certain links that are not allowed. So first one, you are not allowed to show link between two data store. So this is first rule. So whenever you have link between two data store, either you made a mistake or if this really exists, you have to input a process in between the two. Okay, there's data extracted from employee, there's a processing being done, and this is sent to check reconciliation. So either it's a mistake, or if there's a real need, then you have to include a process in between the two. So here it is. You can't have a data flow between an entity and a data store. So how to solve this problem? A process is put in between. You can't have link between two data store. So how to solve this problem? Again, a process is inserted in between, and you can't have data flow between two entities. A process is inserted between. Now, if you realize it's a mistake, just remove the data flow. Okay, if you realize that this should not be here, just remove it. But if there's an importance of having this, then you have to include your process in between. And bearing in mind that, very important, so when you're doing this kind of stuff, that the limit of 9 processes. Okay. Don't include a process that's taking input data A and outputting the same data A. Okay, so it's useless. Very often, students make this mistake. So we input student detail into process, and student detail is going. Unless there's a student detail coming in, there's registered ID going somewhere, and then you have a student detail that goes to a data store. Okay, but if there's only student detail coming, student detail going out, there's no need. Okay, you need to improve your diagram. So data flow cannot be split like that. So we should not show this. It is from that process to process 2, and from that process to process 3. It's not splitting in between. Same here, it cannot be merged in between. So if you have 2, it's not splitting in between. Going to process 3, this is how it should be shown. So from process 1, it goes to process 3. From process 2, it goes to process 3. Okay, so be careful about your diagram. So a data flow can combine many data elements. So to simplify your diagram, for example, you have customer surname, customer first name, customer address. Rather than putting 3 data flow, you can just say customer detail, okay, to simplify your diagram. So as far as possible, we avoid this because it's difficult to follow, but sometimes you might see in diagram. But as far as possible, let's avoid this bidirectional. Just put it as one data flow going to the data store and one data flow coming from the data store. Because very often the data that goes and the data that comes might be different. and you have to label your data flow appropriately. So here's a sample diagram. So you can easily identify the mistake that has been made. So it's employee file and employee entity. You cannot have data flow between an entity and a data store. Here, process number 1, you see that there are only inputs coming. You are not allowed to have process with only inputs. So every time you're going to draw a diagram, you have to go through this procedure to identify the mistake. Here you have data flow between 2 data store. It should be avoided. And as far as possible, you should avoid this bidirectional. But you see in the diagram, it has put it because it's the same employee record. That's why it has put it. But as far as possible, let's avoid it. Okay, go through this case study. Then I'll show you how to draw the DFD. Okay, I guess you've been able to go through the case study. So first thing, when you tackle any case study, normally I advise students to go through it 3 times. First time is to read to understand. So if you've gone through the case study, I guess most of you have understood the concept. It's about a university processing application for postgraduate. You have home graduate, you have graduates from other institution. If you're a home graduate, we just check your result. If you are from other institution, we need a reference. So basically, first step is to go through the case study to identify, to understand the case study. Okay, once you understand, it's going to be easy for you to tackle the case study. The second thing, you go through the case study again, you try to identify processors, entities, data store, okay? Potential processors, entities, and data store. We know that processors will start with a verb followed by an object. Data store are nouns where they are repository, and entities are providing other inputs and outputs. So this is the second, when you go through the case study. And the third one, then, once you've been able to highlight this, then you start drawing, okay? It will take some time, but once you understand, once you've identified the process, the data store and the entities, it's going to be easy for you to draw the diagram, okay? So let's go through the case study. I'm going to show you how to draw the DFD, but I'm not going to do it for all case studies. So this is the process that you're supposed to do, okay? So a college processes application for its postgraduate course from home graduates and those from other institutions. Okay, so if you go through case study, so you can see that we have entities, home graduates, other graduates. or simply someone might say they are applicant. Okay, so
Oh,
either use home graduate,
yes.
other graduates, or you can combine. It's up to you, but this is what you get from the first line. The admission section records the date of receipt of all admission in the application book. So basically you have applicants, they make application, you have a data store application book, and there's a process to record that. Okay. Home graduates are accepted if they meet the entry requirements. This is also checks again list of previous examination results, the record section. So you have applicants, you have record application, you have the date that goes to application book. So please note that we are labeling the entities, the data flow, the process with unique identifier and a name starting with the verb, and we are labeling the data store, D1 application book. Then second one, you have entry requirements that we are going to use. We are going to take the application. Recall that I told you a process is useless if you have application coming, application going, but in this case, there's date that is going to application book. So you have one input, but two different output, one going to your data store and one going to the next process, or depending on the way that it is done. So someone might say that you have application, you have record application, it goes to the date and the details go to the application book. And then from here, from the application book, you extract the data to go to the next process. So this is also allowed, okay? Because is it someone, you cannot see the slide? Is it okay?
It's okay.
Yes, okay.
It's good.
Okay, so let's proceed. In case you cannot follow, please don't hesitate. So I was talking to you about the way the diagram will be, okay? So here you see that you have applicant providing an input, it goes to the process, and then from the process, it moves to another process. This is the data flow. But someone might come and say that you have the application, this is recorded in the application book, the data goes to the application book, and then I extract it from the application book, I go to the second process. This is also correct. Okay, you have, as long as it's abiding by the rule, that is, there's input, there's output, there's data that is extracted from a data store. It's not, for example, a link between entity and data store. Okay. So here we have the second process, check entry. So we check entry against the entry requirements stored in the data D2 entry requirements, and we take exam result because this is also check against this of previous examination result. So we are shown that the data store somewhere D3 called exam results. We extract the exam result. But it's also possible, like here I'm using D2 and D3. Someone might say that there's a single data store where you have both entry requirements, exam result. This is also possible. Okay, so the one thing that you have to remember, case studies that you're going to tackle, you have multiple solutions to this case study. There's no need that there's one single answer for every student, but at least the rules that I'm explaining, the notation that I'm explaining, the process that is required is here. Okay, it might vary in terms of data store, it doesn't matter. So other graduates are rejected if they don't meet the entry requirements, even if they do a reference is sought. If it's satisfactory, the graduate is accepted. So you have applicant, there's application, there's date goes to application book, there's record application, there's the application that goes to check entry, there's entry requirement, then says, if it is home application, we go check the results. So there's new process check result. If it is foreign application or other institution, we check reference. Okay, so check reference, make a request to your referee, the referee send the reference. Then all applicants receive a letter from the college advising them if they've accepted or rejected, and the date is sent to the application book. So again, you have applicant, record application, you have application that goes to second process, check entry. There's the date that is recorded whenever we are checking. There's a rejection letter that is sent if you don't meet the entry requirement. If you meet the entry requirement, we need to check the results for local application. So we check against exam result, and there's a letter that goes to the applicant, but the date should be recorded. So we are duplicating the application book. This is allowed. So D1 application book, we duplicate the application book. Applicant also can be duplicated, but you use the same name. You see, applicant is duplicated. This is allowed. But processes are not allowed to be duplicated in DFT. You can duplicate data store. You can duplicate entities for clarity purpose, for simplicity. Otherwise, my diagram, there will be an arrow that takes here. Sorry. So there will be an arrow from here that goes to here. Well, for simple diagram like here, we have only 4 processors. It's fine. But if you have 9 processors, you might see arrows that is crossing other process. I don't like this. Okay, so you have to be careful about this. And when you are checking reference as well, check reference, we have a request that is made to the referee sends the reference, and then you send the letter to the applicant, and there's the date recorded in application book. Now, when you are doing that check reference, someone might say there's a data that needs to be extracted directly from the application book rather than from this check entry. Okay, it's up to you. I told you that you can either, like for check entry, you can take it from this process here, or you can take it from the data store. Okay, this is also acceptable. It's an appropriate solution. Okay, so let me stop sharing. It's moving a lot. So this is the final diagram that we are getting. Yours might be different, but one thing that you have to do after drawing the diagram, make sure that all entities are labeled. Okay, all entities are providing inputs or expecting outputs. You can see here applicant providing input, expecting a rejection letter, referee, a request going to referee, the referee providing an input, the reference, the applicant again is expecting a letter coming to them. Now the actual data is letter, is not the physical letter that we are talking about. Okay, it's the data that is transmitted. Okay, in most systems that we are going to implement, when we read, it will look as if it is a physical document, but since we are computerizing, we are considering only the data. Okay, so don't worry about the label that we put later. All data store are labeled. D1 application book, D2 entry requirement, D3 exam results, and it can be duplicated. Like application book is duplicated. Entities also can be duplicated. All processes are labeled with a unique identifier and a verb followed by an object. We code application, check entry, check results, check reference. We don't say who is doing the task. All processes will have both inputs and outputs. So input application, output application, and date, input entry requirement, date, okay, input application to check entry, check results process with inputs, exam results and home application, letter going as output, check reference, there's input of application, there's date going out, there's letter that is going out, there's request going out. Okay, so you see that all processes has been labeled, inputs and outputs. In this case, there are only 4 processors. The limit is 9, but this is a simple case study for us to understand. And there's no link between 2 data store. So you see there's no link between 2 data store. There's no link between data store, sorry. There's no link between data. I don't know why it's going back. Maybe there's a animation time. So let me remove. I don't know why it's doing that. Oh, I think because I've reached the end of the lecture on Zoom. Okay, that's why I think it's stopping my presentation. It's okay, we are almost done. So you have to check that there's no link between two external entities. There's no link between two data store. There's no link between external entities and data store. You can easily verify that in the diagram. Okay, that's it with DFD. Any question? Anything you want to clarify?
No, sir.
It's okay.
It's okay.
Sir,
Yes.
when you are talking about we have maximum 9 processors
Yes.
in are you talking about real life or just for the tutorials that we will be doing or case studies that we will be doing?
All DFDs for clarity, for simplicity. And I told you, if you have, let's say in a system like University of Mauritius, you have 100 of processors, you do several diagrams. We are going to discuss that in Exploded DFD. For example, you're going to do a diagram DFD for library, you are going to do one for finance, one for exam section, one for registration with 9 processors. If you have 10 such diagram, you're covering 90 processors. And don't forget, we are going to do minimal redundancy. Whatever has been mentioned in the top level, we are not going to repeat it in subsequent. The first level diagram is just for an overall view of the whole system. Sometimes going to be difficult, but that's why we have Exploded DFD to help us later. Yes, any other question? Okay, so if you don't have any question, we stop here. We are good for today. The tutorial has already been posted online, so try to start the tutorial, and Wednesday we are going to start correcting. There are 4 questions. Try to attempt all questions, and we are going to discuss during the tutorial sessions. It's okay?
Yes.
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 Yes,
Okay.
sir.
Yes. Sir.
Yes,
Bye.
sir.
Bye for today. See you Wednesday.
Bye.
Everyone.
Goodbye, sir.
Au revoir, Michel.
Goodbye,
Okay.
sir.
Thank you.